Hello guys. It turned out to me by some students that the questions are a bit tricky and they are facing some problems to apply the concepts that we have learned in actual questions. And it is not plausible to discuss all the questions in live sessions. So I have thought of going this way. Like what I will do after sharing the files with you guys and after like dealing with the concepts in the live classes and discussing some questions, of course, just to there should be some light thing. But after that, I will just like create these video solutions and I will upload them in a recorded manner so that you can refer to them. But there is a catch here. Please don't watch these videos without attempting the questions. Please don't watch these videos. And even after, if there are some doubts, even after these videos, then we can tackle those doubts in the next live class. So that is a better strategy, I would say. Uh, this is all what I can do from my side. So I'm trying my possible. Okay. So this question I already discussed, and it's a simple question. If a number is divisible by 2 and 3 is divisible by 6, if it is not divisible, if it is, we cannot be sure about 4. So we are no, we have already learned the art of assumption. So what is the art of assumption? Let us assume a number 18 divisible by 2, yes, divisible by 3, yes, divisible by 6, yes, but not divisible by 4, no, not divisible by 4. So only one conclusion is true. Second, this number, this obviously this question also we dealt in two ways. So one thing is this, like you can write any number x, y, z as 100x plus 10y plus 10 plus z, and y, z, x can be written in similar manner as 100y plus 10z plus x, and similarly z, x, y can be written as 100z plus 10x plus y. So when you will add all of them, it will become 101 into x plus y plus z. Now 101 is equals to nothing but 37 into 3. So the number is used by this, and this, but not this. So our answer will be this. Now suppose this can be done again using the art of assumption. So let us assume a number 124 where x plus y plus z is not a multiple of 3. Obviously this satisfies this thing. So 124, 241 and 412. How much this? This is 777. Now this is divisible by this. This is divisible by this, not this. You can check it by divisibility rule of 9 also. Divisibility rule of 9. Okay. So the sum of digits, that is 7 plus 7 plus 14, 21. 21 is not divisible by 9. So I rest my case that this number is not divisible by 9. Now this question I also discussed. I guess this number, if this number is divisible by 3, this number is divisible by 3, then how many values of b are possible? So this number, the sum of digits is 4, 2 plus 2 plus 5 plus 2 plus 7 plus 4 plus 6 plus b. So this is 30 plus b. This 30 is already divisible by b. So b either can take 0, 3, 6 or 9. So there are 4 values that are possible. Okay. So these are the questions that I have already discussed. Now in this question, the number is divisible by 4 and the number is divisible by 6. LCM of 4 and 6. Why we need to find? Because if there is a problem of common remainder or common divisibility, then we need to find the LCM. LCM of 4 and 6 is 12. I've already told you how to reach this. Now, if a number is divisible by 12, then the player can play either football or cricket both. So what we need to find, we just need to find the multiples of 12 between 1 to 100. Between 1 to 100, we just need to find the multiples of 12. And if you can recite the table of 12, then you know that 12 into 8 is 96 and 12 into 9 is 108, which is obviously greater than 100. So we will take this. So there are only 8 students that can play both cricket and football. So this is how we will proceed. This question I've already discussed. This question I've already discussed. See, whenever you see this reversing of digit, this one thing what we keep in your mind, that when we will reverse these digits z, y, x, so the this is divisible by obviously z minus x or mod, something like that. Now this number is divisible by 7. The number on reversing the digit is also divisible by 7. That means this should, on the right hand side, should also be divisible by 7. And now we know that 99 is not divisible by 7 because 98 is divisible by 7. 98 is divisible by 7. Or you can apply the divisibility rule of 7 that I have already told you, if you want. So something like that can happen. But simple table of 7 when you will recite, so you will find that 7 into 14 is 98, and so 99 is not divisible by 7. Therefore, x minus z should be divisible by 7. And now x minus z, now is it, they both are single digit and distinct distinct, that means they are not equal. That means x minus z should be equal to 7. X minus z should be equal to 7 only when 9 or 2 or 8 or 1 or and interchange also. So there are four three digit numbers that are possible using these digits. So either it can be 2 dash 9 or 9 dash 2, 8 1 dash 8 dash 1 or 1 dash 8. So these are the numbers that are possible based on the above information. Sixth question, it is quite easy. If we will do it using the assumption, so suppose r and s are different integers, both are divisible by 5. Let us suppose r is equals to 5 and let's suppose s is equals to 10. Okay, so r minus s r minus s minus 5 divisible by 5. Yes, r plus s is divisible by 10. R plus s is equals to 15. That is not divisible by 10. That is not divisible by 10. That is not divisible by 10. Therefore, B will be the answer. We are here finding not necessarily true. So the art of assumption will help us to negate these things. See, in this question is quite a tricky one, I would say, because there is no easy way to do this apart from using all the options. Apart from using all the options, there is no easy way that I have found to do this kind of question. What we can do here is, uh, wait a second. What we can do here is just let us create three rows, four rows, five rows, and six rows. So based on these combinations, what we can do, we can just go for the rows. Like if the and the each row contains three less children than the row in front of it. So it can be something like that: x plus three and x plus 6 for three rows, something like this. And the total number should be equal to 630. The total number of children should be equal to 630. And this will become something like 3x plus 9 is equals to 630. And so 3x is equals to 621. And x is equals to 621 by 3. So that will give you 207. So it is possible. Similarly, when you will do for 4, 5, 6, so that is the only way you can do it. That is the only way you can do it. You will find that six rows are not possible because the answer will come in decimals, and that cannot be true for children because children are entity that cannot be divided. This way you will proceed this question, and I am just giving you a hint. I want to try it, but the way to do this is only using options. Otherwise, the question will become very complicated. And see, in this question, when the possibility is asked, it is better to do with the options. Because we just need to negate if it is possible or it is not possible. Like there is no other way to do this. And some like I won't say it as a technique, but the good thing is that like if you have applied it on 3, then apply it on 6. Don't apply it on 4 and 5. Like after checking for option A, go for option D, or like just start from the option D and then go for A. Like the extreme options, like A and D, should be first to be checked. That is just an observation from based on PYQs, and there is no nothing logical behind that. Okay, so this question I've already discussed. Like we just need to find the power of prime. So 15 give us 1 3, 12 will give us 1 3, 9 will give us 2 3, 6 will give us 1 3, and 3 itself will give us 1 3. Okay, so 1 2 3 4 5 6. So that's how you count. Like just all the composite numbers, try to turn them into prime factors, and then just count the powers. Like just count the number of primes that are available. That is the only way to do these things, and no other way to do these things. Okay, what is the smallest number greater than 1000 when divided by any other remainder leaves the remainder of 3? So if there is a remainder of 3, what we do, we can just say that if 1063 leaves a remainder of 3 on division of any number, then 1060 should be divisible. Similarly, 1070, 1080, 1180. Now there are many ways to do this. Either you can just go for the LCM, which in this case will be 180. So the number should be divisible by the LCM, one case. Otherwise, individually should also this number should divide them. So you can check for 6 or 8. That is the sum of digits. Sum of digits you can check. Sum of digits. You can check for sum of digits. So in this case, only 1080, 1 plus 8 is equals to 9, which is divisible by 9 as well as 3. So it will be divisible by 6 and 9. No need to check other numbers because this will give you sum of digit as 8, not divisible. This will give you sum of digit as 7, not divisible. This will give you 10, not divisible. So our answer will be this, and this is how you do these questions. Now, this question was not about the remainder question. This was more about prime factorization. I would say like you have to do this kind of question by care, because they seem tough as first. But if you know that this is 13 into 97, like just try to break the number in prime numbers, and the process is like you will first try from 3, 3, 5, then 7, then 11, and then 13. So ultimately when you will reach that it is not divisible by all these numbers, so it is only divisible by 13. When you divide by 13, you will find that it is nothing but 13 into 97. So when you will reach that it's 38 to 97, 97 will cancel 97, and 13 will cancel this thing, and then you will find that the remainder will be 0, because it is completely divisible. There will be no numerator left when you will apply this maths. So you will write it something like this: 91 into 92 into 93 into 94 into 95 into 96 into 97 into 98 into 99. And this question seemed to be very complicated, but when you will write it as like 13 into 97, and this is this, and this is this. So suppose these two numbers will leave a zero remainder, and as I've already told you that a remainder we can perform all the operations that are being done in number. So when you will multiply anything with zero, so the remainder will be ultimately zero. So if you are not able to understand in that way, then you can look at it that manner also. But if this number in the denominator, if it is completely cancelled out, if it is completely vanished, then the remainder will be zero. That is the point to be noted. Okay, now here comes the toughest question of all the set, I guess. So this is not tough at all, but this is time taking. This is lengthy, I would say, and I want to discuss in this 2022 paper discussion, but I will just give you a quick review of that. So what we have done is that the question. Let me just know you how to read this question. If the whole number is divisible, how many digits are there? 7 digits are there. So the number is the 7-digit number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7-digit number, and the complete number is divisible by 9, and as the sum of digits like 1 plus 2 plus 4 plus 5 plus 7 plus 8, 8 7 is 15, 15 plus 5 20, 20 plus 4 24, 24 plus 3 27, which is already divisible by 9. Therefore the last digit should be occupied by 9, because if 9 is not in that place, then the number will be not be divisible by 9. I hope it is clear. Okay, now apart from 9, if that thing, uh, last six digits are divisible by six. Six divisibility means that both divisible by 3 as well as 2. If it is divisible by 2, then this number should be even. This number should be even. And then again, for the last 5 digits, the number is divisible by 5. The number is divisible by 5, that is this number, because 0 is not there. For the number to be divisible by 5, the unit digit should be either 5 or 0. And 0 is not here, so the unit digit will be 5 in this case. And now the last 4 digits, for the last 4 digits, the number is again divisible by 4. Therefore, the last 2 digits should be divisible by 4, and this digit should be even. This digit should be even, which in this case are 2, 4, and 8. Which in this case are 2, 4, and 8. We are not sure about these are number divisible by 3, and the last two numbers are divisible by 2. That means this digit is also even, that is 2, 4, and 8. Now we will combine all this information. To get something like this. This is either 1 or 7. This is even. This is either 1 or 7. This is again even. This is 5, and this is again even, and this is 9. This is the 7-digit number, and we need to find the sum of the middle 3 digits. The middle 3 digits, we need to find the sum of these things. Now when you will look at the options, uh, in this place, in the place of even, either 2, 4, and 8 are possible. Now when you will plus 5, 8, 13, there is no option, all options are less than 13, so 8 cannot be there. Then you will add 5 plus 4, 5 plus 4 9, and 9 plus 7 is 16, and 9 plus 1 is 10. So this is also not the case, so there will be 2 only. At this place there will be 2. So 5 plus 2, you have got that 7 is the sum of these two digits. Now either 7 or 1. If you will add 7, 14, which is not there in the option. When you will add 1, 8 is in option, so 8 will be the answer. So this is how you will apply all the samdams and ways. Like you will look for the options, you will look for the information that is given. So that is a lengthy question. But when if a same question is repeated, then you should be able to do that. Now, this is a typical question that is being asked every year. This is the question based on cyclicity. This is the question based on cyclicity that we have learned. Now, what we need to do in cyclicity, see, whatever the concept I've told, if you're even if you're not able to grab this thing, just remember that the cyclicity of 2, 3, 7, and 8 is 4. So the standard rule applies, and that is the coolest way to find the answer. So how you do that? You just divide 2019 by 4, or any number that is given in the power by 4. You just need to find the remainder. And how you will find the remainder? You will find the remainder that this is completely divisible. When you will write 16 here, uh, and 3 will be the remainder. So 3 will be the remainder. So if 3 is the remainder, then this number 32019 is equivalent to 3 to the power of 3 based on this rule. Just remember this rule. If you are not able to grab this concept, just remember this rule. If the remainder will give you the power to which this equivalent, and for this equivalent power, if you know the unit digit, then the unit digit will be same. And how to do that, because see, it's very easy. Just remember the uh, initial powers like 3, 9, 27, and 81. These are the places, and for the 3 to the power of 3, the unit place is 7. So 7 will be the answer. So just remember these basic powers for the number 2, 3, 7, 8, and these will be the questions that will only be asked. This question 13, that was done based on the thing that I've told you. So we just form the triplet. We just form the triplets. Rule of triplet that we have formed. So we just form the triplets 037. We just found these triplets, and we just found the remainder. So in this case will be 2, 1, 5 plus p and 5. Now what we will do, when we will apply the same thing that we were doing for the 11, the divisibility rule for 11, we'll pick up the odds and subtract even from them. So it will be like 6 minus 7 plus p, 6 minus 7 plus p. Now you will get that this should be equal to 0, this should be equal to 0 or a multiple of 7. It can only happen from the options. When you look at the option, only when p is equals to 6, because then only it will give some minus 7 or 0 or something like that. So that should be the case. It should be 0 or multiple of 7. Then in this case it will be equal to 6. So okay, now for this question, see, for the trailing zeros, as I've already told you, for trailing zeros, or maybe you may say power of 10. The single thing is that 2 into 5 is equals to 10. So it is the same concept as the power of prime. You just need to prime factorize all these composite numbers from there, and you just need to find the power of 2 and 5, and whichever the power is minimum, you will calculate that. So when you will power of 2, when you will calculate power of 2, when you will calculate power of 2, so 2 is here because 2 into 3 is 6. So here comes 10, and 2 is also here because 2 5s are 10. 2 5s are 10. So here comes 6. 2 is also here. 3 into 4, and 4 is 2 square. So here comes 30, because it is something like there are two 2's in there. 2 into 3 is there. So for 15 power, there will be 30 powers of 2. So something like that. So it becomes 46. That is the power of 2. Now you will calculate the power of 5. Power of 5. How you calculate the power of 5? Here from 5, from 10 you will get 6, from 15 you will get 12, and from 25 you will get 14, because 25 is 5 square. So this will give you 37, and 37 is smaller number. That's why 37 will be our answer. That's why 37 will be our answer. I hope these things are clear after this discussion. Now next question. Suppose x is the smallest number greater than 3, such that when it is divided by 6 or 8, the remainder is 3. Y is the smallest number greater than 2, that when it is divided by... See, this is the again the problem of common remainder problem. Say for 6 and 8, common remainder for 6 and 8. So the LCM of 6 and 8 is 24. Now, if the remainder is 3, the number will be 27. That is 24 plus 3, as I've already told you. When the common remainder is 2, the number will be x is equals to 26, that is 24 plus 2. X minus y they have asked, that will be 1. 27 minus 26. So that is a simple, easy application of LCM. And as I've already told you, when you will find two numbers and a common remainder or a common something like that, then the concept of LCM will come. When you will add that remainder to this thing, you will find the requisite number. And if the number is completely divisible, then it is the LCM only. Then there is no need to add something because the remainder is zero in the case of completely divisible. In this question, okay, see, it's a typical question of remainder, and I want to solve all of your doubts. I want to solve all of your doubts using this question. What do you think? Like, if x to the power of y, something like that, and it is divided by 7, 3, or any number, that is the only case that you get 7, 3, 5, or something like that. Any number that you get. So, what you need to do? You need to do a remainder with a power. You just need to raise x to some certain power that will give you remainder either 1 or minus 1. Why are we doing this? Because 1 to the power of n is always equal to 1, and minus 1 to the power of n, minus 1 to the power of n is equal to either minus 1 if it is odd, or 1 if it is even, something like that. You can check it from yourself, like minus 1 into minus 1, it is 1, minus 1 into minus 1 into minus 1, it is 1, minus 1, and then again, if we'll do it 4 times, then it becomes 1. So if the power is even, then it becomes 1, and if the power is odd, then it becomes uh, like that. So what we do, so we just try to raise x to certain amount, that so that we get 1 or minus 1 as a remainder. And obviously in every case you will find that you will not find a question that in that case it is not possible. So when you will check for 10, the remainder is 3. Then when you will check for 100, the remainder is 2. When you will check for 1000, you will be surprised that the remainder is minus 1, because 7 1001 is divisible by 7. 1001 is divisible by 7. 1001 is divisible by 7. Therefore, you will find that the remainder for 1000 is minus 1. So you find the remainder for 7 is minus 1. Now what you will do, just try to divide 10 to power 20. It's like you can write it as 10 square into 10 to power 18. That it means like breaking 18 plus 2, breaking 18 plus 2. Now 10 to the power 18 can be written as, now 10 to the power 18 can be written as 10 to the power 3 to the power of 6. And as the power is even, the remainder will be 1. The remainder will be 1. So we just need to check for 10 to the power square, and we already know that the remainder for 100 is 2. So the answer will be 2. So this is how you proceed. This is the only way to do these questions, and this is the smartest way to do these questions. Otherwise, there is no other choice. Just try to divide this power. If you are good at this dividing these exponents, no, there will be no issue, because this ultimately you will find with practice. You will, like, you can just find the remainder using your phone's calculator in the beginning. That can there is no issue in doing that also. Okay, so I hope you're getting my point. I will repeat again the process. Like, you will just have to raise the powers. You will just have to check that either the remainder should be 1 or minus 1. Then you will have to break the thing in such a way that this power is well utilized. Like, the power of 3 can be well utilized to cancel out 18 digits. The power of 3 can be, like, you will just run through the table of 3. 3 1 is 3, 3 2 is 6, 3 3 is 9, 3 4 is 12, 3 5 is 15, 3 6 is 18, 3 7 is 21. So out of these 20 powers, you can make the remainder of 10 to the power 18 as 1 or minus 1, depends on the power you are getting. It's either 1. So you can write 10 to the power 20 as, this is how the law of exponents work. You can write it as 18 plus 2, and then you can write it as 10 square plus 10 to the power 18. Now this 10 to the power 18 can be written as 10 cube to the power of 6. This is how you break this thing, just to cancel it out. There is no other purpose. Like, this is calculation I am doing, which we usually do it in our brain. Like, this, for this whole thing, the remainder is 1. The remainder is 1 because the power is even. If the power would have been odd, the remainder would be minus 1. That is the thing. Now you are left with this just 100. 10 square. 10 square means 100. Now just you need to find the remainder for this 100, and then you already know. You can do it using any simple calculation, like 7 into 14 is 98, and therefore 100 will give you remainder as 2. So this is why I'm pushing this too much, because every year there is a chance of getting these questions, and every year there is a chance of getting these questions wrong. Now again, this is a simple question. This should be left as homework because we have discussed the same question. Again, just find the powers of 2, just find the powers of 5, and go for the minimum. Go for the minimum. In this case, the answer will be 98. I have already done that, so I won't be doing it again. But this is the only question that I am giving homework, because this is on the exactly same lines. How many numbers from 1000 which are not divisible by any of the digits? This is a typical question. This I have already marked star. Many of the students might have found difficulty in doing this question also. So there is a proper way to do this thing. Like you just have to find the non-divisible number. See, just understand the language of this question. So it is going to ask you the numbers which are not divisible by any of 2, 3, 4, 5, 6. See, like numbers like 1, numbers like 7 again, because 4 is divisible by 2, 5 is divisible by 5. Then again, not 8, not 9, not 10, again 11, which is not divisible by any of the numbers. See, something like this. Then again, you are going for 13, something like that. These numbers, either the multiples of these numbers which are not divisible by any number, and either or otherwise the multiplication of these numbers or the prime numbers. So these are the numbers that you need to find, and it is so hard to find these numbers. But what we can do, we can just use the permutation and combination. How to no, don't get bothered about this process. You will learn more about these things when we will do the topics of permutation and combination. But for the sake of this question, just bear with the method. Like for every common sense understanding, like every one out of two numbers are divisible by two. Like one is divisible by two, two is divisible by one is not divisible, two is divisible, three is not divisible, again four is divisible. Out half of the numbers are even, half of the numbers are odd. Similarly, two out of three numbers are not divisible by three, and four out of five numbers are not divisible by five. For three, for five. This is what we are doing now. 990 is the largest number among this thing which is divisible by all the three numbers. So just bear the process. Like don't uh, if you will multiply, if you will find all by doing this multiplication, you will find all the numbers up till 990 which are not divisible by any of them, and the answer is 264. Now between 991 and 1000, 991 and 997 are the two numbers that are not divisible by any of them. Then the answer will be 264 plus 2, that is 266. Why I am focusing on this question too much is that at least you remember the answer, or at least you remember the possible method, because this question might come in may appear in UPSC CSAT. Now again, this thing, the smallest number which when added to 10,000 becomes divisible by this. Okay, so what you can do is like you can go for the divisibility test of 20 first. If you go by the divisibility test of 20, because all these numbers should follow that thing. So if a number is divisible by 20, it should be divisible by 10 also, because 20 is equals to nothing but 10, 2 into 10. So that means this option is incorrect. Now from the left from these questions, now what you can do, if it is divisible by 10, so for 24 it should be divisible by 8. For 24 it should be divisible by 8, something like that. So this is how you will be doing. So last three digits should be divisible by 8. Last three digits should be divisible by 8. Now this 080, 800, 120, and you are asking, they are asking for basically they are asking for the smaller digit. So that will be the number, that will be a number, because 80 is smaller than all these things. 80 is smaller than all these things. So other than this, like just go for the LCM again. LCM, that will be 180, and then 180 you will try to find like the multiples of 180. That will give you the same answer, and this will be the answer. I hope it is like this. I've already assumed, like if a number is given like this, then you can assume as x is equals to 2, because the remainder in this case is 2. Now x to the power is equals to 128. 128 will give you remainder as 6, because 61 into 2 is equals to 122. This was an easy question, I guess. Now for the question number 21, again similar lines, again on the question. See, this is how I am talking. Like this is on the again on the similar lines, and UPSC has been asking again. So this is from the year 2019, asked in the CISF Assistant Commandant, and now from the year 2020, every year a kind of this question is asked every year. So this I will left you as homework, because this is a simple question of common remainder. This is a simple question of common remainder. The answer will be 905, because the LCM will be a multiple of like 900. Will give you something like that for and then remainder. That means you will have to minus the remainder. This will give you 950. This will give you 900. This will give you 990. This will give you 750, and then you will start from the largest number, because they are asking for the largest number, and then you will satisfy all the possible cases. You will find that 905 is the answer. In this case, we'll assume 9 as a number, 9 as a number which is divisible by 3 but not divisible by 6. And then you can check that this is number, this is 28 which is divisible by 4 and other are not divisible by 4. So this was an easy question. Again, this same thing. See, when we are getting in the for the unit place, if your number is divided by a unit place, a number is divided by a unit place, a number is divided by 10, the unit place is the answer. And when the number is divided by 100, last two digits are the answer. Last two digits are the answer. So in this case, when you will try to find the last two digits, so like 5 2s are 10, 10 5s are 50, 50 into 1 is 50, 50 into 7 is 350. So 50 will be the last two digits, 52 will be the last two digits when you will perform this multiplication. So last two digits will be the remainder when the number will be divided by 100. So that is what the catch in this question. Okay, same on the same lines. Like this is what I was asking the common remainder question. Like this will be 1010, this will be 1020, this will be 1120, this will be 1220. Okay, now go for the sum of digits. Now go for the sum of digits. Go for the sum of digits. It should the sum of digits should be divisible by should be divisible by 3. Yeah, let us, if we will check that the sum of digit here is 4, the sum of digit here is 5, the sum of here digit. So in this case only the sum of digit is divisible by 3. Same pattern, same pattern. The question was asked in CSF in 2019. In the year 2020 it was asked in CSAT. In the year 2021 again it was asked in CSAT, like the one we did here. This question, this was 2022 question, again asked in 2022, previously asked in year 2020 in CSAT itself, and originally asked in the year 2019 in CISF exam. So that is what I have told you, that the pattern is very much repetitive. Now this question, the which have digit 4 as digit but not divisible by 5, this kind of question, because it is only about from 1 to 100, this you should do by the count, by counting only, and no other way, because we want accuracy. Like if we would start from 14, leave 24, then 41 to 41, 42, 43, 45, 46, 47, 49, 54, 74, 94, all of the numbers are divisible by 4, so 12 will be the answer. When you will count it like that, no, so 12 will be the answer. So I raised my case. This is how you will deal these questions. And please, again, it's a reminder, don't refer to this video without solving the questions. And after solving the questions, please refer to this uploaded video. So this is we going to our methodology. We'll discuss some questions in class. We'll discuss all the concepts in class. And after giving you the PDF to attempt, and after giving you the PDF, I will upload these kind of video solutions in your content tab so that you can access them for your reference and for revision also. When you will doing the questions again or something like that. So this is a small effort from my side. Thank you, everyone.